For MPLS traffic engineering, we have now 5 routers here. Initially, we'll have path option as dynamic. So for 2 reasons, it will go straight from router 2 to router 4 in order to reach router 5. One, between router 2 and router 4, you got more bandwidth, say gig Ethernet. 2, number of hops are less, so cost is going to be less, just one link. Whereas via router 3, there are 2 links, 2 to 3 and 3 to 4, and the bandwidth is also less. But you know one thing, according to OSPF, both gig Ethernet and fast Ethernet cost is going to be same because auto bandwidth is auto cost based on bandwidth is calculated by keeping 100 as the reference, as the numerator. Do you know that, or you want me to explain that? Should I explain more, or you know it?
Please.
Okay, let me explain. You see, when cost is equal to 100 by bandwidth, so what is the reference bandwidth? 100. Here you got 1000 meg, here you got 100 meg. So now if I calculate the cost for this, it's 100 by 100, which is 1. If I calculate cost for this, 100 by 1000, which is also 1. There is no fraction numbers allowed. So cost on this link as well as that link is same. But still it will go via this path because here another 1. 1, 1, 1, 1, everywhere 1. So cost to reach between R1 and R5 is 3. If you go straight like this, it will be 4 if you take 1, 2, 3, and 4. 4. Lower the cost, better is the route. Lower the cost, better is the route. So this is the elected route. When this link goes down, automatically it will take this route. Automatically. When this comes back, again it will fall down to this path. That is dynamic path option. Anyway, if you want OSPF to have that ability to differentiate between gig Ethernet and fast Ethernet while calculating the cost, the dynamic cost, auto cost, you have to change this numerator value. By default 100, but when you make it as 1000, then this is going to be 10 and this is going to be 1. Is that right? 1000 by 1000 for gig Ethernet will be 1, and this will be 10, and this will be 10, and this will be 10, and this will be 10. Now the cost via this route is 10 plus 1 plus 10, which is 21. Via this path, it is 10 plus 10 plus 10 plus 10, which is 40. Okay, so you need to change the numerator if you want this. The default is 100. First of all, let us do with the default, then I'll show the changing path cost, calculating the command to change the numerator. I'll enable the protocol OSPF along with IP address in this node using this notepad. You cannot put MPLS IP command on the loopback interfaces. We know those things. Okay, the CEF is important. If it is not enabled, you have to enable. According to me, CEF is enabled. So I no need to give this command IPCEF. See, let me show you. It is already there. I want to show you that. Show run, you will see. See, IPCEF command is already there.
Is that command by default?
Yeah, by default it is enabled.
Okay.
By default on all Cisco routers, CEF is enabled. You can disable by saying no IPCEF.
Okay.
It is enabled, so you no need to give this. But why in documents they show you the command is in case if you have disabled earlier for some other reason, you should enable it. That's why they show the command. So let us also pretend that we have disabled CEF. So I'm going to say IPCEF. But don't think, this command is important even if it is enabled already. No. Though it is enabled already, I'm just putting this because to follow the standards. Like document says, in case if CEF is disabled, it won't work, so you put this command. That's why they show you in the document. But in our case, I'm very sure every router has got CEF enabled. Truth is, I don't want to put this command. Let's not do it because it's already there. Okay, I removed it. Alright, OSPF is running. Copy. I'll put it on router 1. Next. Let me finish configuring router 5. Right. So 1 and 5 is over. Let us do router 2. Router 2 has got 3 interfaces. F00 going to have 12.2. This exclamatory mark is not mandatory, just for your understanding, neatness. I'm putting that. All right. All right, let's quickly see whether we have done it correct. Which means it is correct. I see neighbor coming up, but I would like to check once whether IP address is properly given 24002, 23002 on F0/1, and MPLS is enabled, OSPF is enabled, F0010. Okay, looks good. Now router 4 I want to finish, then I'll come to router 3. Router 4 will have this one as 4, and F01 will be 45.4. F00 will be 34.4. Loopback will be 4444. Alright, now let us copy this and put it on router 4. Okay, now we will see neighbor between router 2 and 5. Okay, 2 and 5 has become neighbor to router 4. Now one last router. In this we don't have gig ethernet. Remove this. And F01 will be 34.3. F00 is 23.3. And this is 33333. This goes on router 3. Now let us go and check the routing table. R1, when I do trace route to 55555 with a source 11111, you will see it will go via router 2 and 4. Yeah, after 2 it goes to 4 and uses MPLS label. And when you check the cost show IP route 55555, the metric is 4. How the metric is 4? Because here 1, here 1, here 1, and then the loopback interface 1. Totally 4 cost. But if you take this direction, it will be 5. Let me shut down one of this port here and show you. I'll go to router 4 and shut down this gig interface gig 3/0. And when you check now, the route will be via router 3 and the metric will be 5. This will become 5. See, it is 5. Now if you trace, it will go via router 3. This is dynamic. Now let's bring this interface up. So one thing I have clearly shown that the auto route happens. Now this is falling back. Give some time. It will fall back. Did I say no shutdown? I did. Yeah, it has fallen back. Yeah. So now it's fallen back. It goes from 2 to 4. What is next?
Jay,
Hmm?
did we figure out a 1 and 5 already?
Again?
Hello?
What did you say?
No, I mean, my question is, did we figure out a 1 and 5 already?
Do you mean have we finished configuring route 1 and 5? Is that your question?
Yes.
Yes, of course, yes.
Okay.
Yes, you see, show IP route OSPF. If you have routes, which means you have already done. Hmm? You have routes to reach 5FFA. See, we have not started MPLS traffic engineering yet. Basic OSPF with the MPLS. Show IP OSPF neighbor, you see a neighbor, show IP, show MPLS LDP neighbor, you see neighbor. What is your question? Did I answer your question?
Yes, because yeah, I didn't see where we configure router 1 and 5. That's why I'm asking.
Okay, the very first router that I configured is router 1.
Okay.
Alright, now we are going to enable traffic engineering. What are the steps I'm going to do? First is MPLS traffic engineering tunnels. I put this command. Secondly, I want to go to the interface F00. Wait a minute. I told you I'll show you the command to change the auto cost. All right. Right now on fast Ethernet and gig Ethernet, the cost is 1. You saw that. What is the cost now to reach 555? It is 4, which means 1 and 2 cost is 1, 2 and 4 cost is 1, 4 and 5 cost is 1, and loopback 1. So totally 4. And when I shut down this port, you saw cost was 5 because one physical interface is extra. From this, what you understand, both for gig Ethernet and fast Ethernet, as according to the OSPF, cost is same. Cost is 1. So did you understand that part?
The second path, I didn't understand. Why is 5?
Okay, I'm going to explain you that. The first path, 1, 1, 1, and the loopback that you're pinging is 5, 5, 5, 5, 1.
Okay.
So totally 4. But in the second
Okay.
part, it's going to be 1, 1, 1, 1, and 1. So if you go this way, 1, 2, 3, 4, 5, isn't it? When you
No, you say
go
where is 1? Where is 1? First 1.
1, 2,
No, no, no. Yeah.
3, 4,
Yes.
5.
Okay.
If you go upper path. If you
Okay.
come via the bottom path, it's going to be 1, 2, 3, 4 only, isn't it?
Yes. Okay.
Now what I'm going to do, I'm going to make this router to understand that this bandwidth is more than this. So the cost of this link should be less than this. How do we do? by changing the reference bandwidth. Right now I say the reference bandwidth is 100 by the bandwidth command. This is the formula. Cost equal to.
Okay, so now you will change
Yeah, I'll
the
change this
cost
formula.
of.
I'm going to change the formula. So after I change, what I'm expecting is this will become 10. This will become 10. This will also become 10, 10, and 10. This will remain 1. Any question on this?
And on the middle of the path, how much it will be?
1. The reason
Okay,
this is 1 is the formula I'm going to turn is from 100, I'm going to make it as 1000. 1000 by bandwidth. What is the bandwidth of a gig? It is 1000 meg, 1000 on top, and the bandwidth on this link is also 1000. So what will be the cost? 1.
one.
Whereas on these links, it is 100 is the bandwidth. So 1000 divided by the bandwidth is fast Ethernet 100 mega. When you cut this, you get 10. That's why I put 10 here. Is that clear?
Yes.
Okay, we are going to see whether what we learned is correct. Now I'll go to router 1 and change the formula. Right now it is showing you 4. After we finish this configuration, it should show around 31, something like that. Let's check. Go to router OSPF and say auto cost reference bandwidth should be 1000, not 100. And this we need to change on all the routers. So it is suggesting you to do it on all the routers. So I'll paste it on all the routers. Router 1, router 2, router 3, router 4, router 5. Okay. Now when I go to router 1 and check the cost, look at this. The cost is 22. How? Earlier it was 4. Now it is 22. Because here it is 10. Here it is again 10, 20. This is 1, 21. And loopback is also 1. Loopback is not 10. Loopback is also 1. So totally 22. 22. If I shut down this port, it is going to be 10, 20, 30, 40, 41. Let's shut down and see. On R4, go to R1. Wait. Ah, look at this. It is 41. Same as what we did. We guessed. Same as what we guessed. I told you this is 10, 20, 30, 40, and then the loopback is 41. 41. Okay, now if you trace route, it will go via the upper path. When you go via the upper path, the cost is 41. I'm going to say no shutdown. Now, if you check from 41, it switch to 22. If convergence happens, it will switch to 22. 22. Now if I trace route, it will go straight from 2 to 4. Okay. So we have also changed the auto cost reference bandwidth. Hope you got this. Shall we go to traffic engineering configurations? Why silent? Tell me something, please.
Sure.
Okay.
Sure. Yes, please.
Now, the very first command we give is MPLS traffic engineering tunnels. We did it. I want you to do this on every router. Let's do it on every router. Okay, on every router in the global mode, we have given this command MPLS traffic engineering tunnels. We have done this. The tunnel is between the edge routers. So on the edge routers, you need a tunnel interface. But before that, we need to enable traffic engineering on the interfaces, and we need to say, hey, interface, you can allocate, you can provide support for traffic engineering up to this much bandwidth you can serve, you can provide. So that command is like this. Interface F00, same command MPLS traffic engineering tunnels. So it's still another interface. IP RSVP bandwidth. That's all. Do show history. So I'm going to put these commands in a notepad. Enable config G, and then this is for router 2 I'm doing. Let's do one thing. Let's finish router 5. End write to memory. This is router 5. Next. On router 3, we have two interface. Okay. So router 3 has got router 1 and router 5 has got the configuration. Now 4 and 2. 4 and 2 has got one additional interface, which is G3/0. Now we can verify here. Show MPLS RSVP. Show MPLS interfaces. Yeah. You see, sorry, not MPLS. I want to check RSVP interface. MPLS is already there. We know it. Show IP RSVP interfaces. RSVP. Yeah, interfaces. See? Very nice, very nice. Listen, wonderful. 75% of bandwidth is 750 meg. I did not mention how much bandwidth it should use, you see? I did not mention how much bandwidth. When you don't mention how much you want to give for traffic engineering, if you don't mention how much should give for traffic engineering, it will give 75% of the bandwidth. 75% of 1000 meg is 750 meg. This is interface maximum. This is flow maximum, means one flow can be up to 750 meg. One flow can be up to 750 meg. If you go and check some documents, for example, if you see here, and they configure, they'll put 2 times the bandwidth under the interface. The reason is, one is talking about the total amount of bandwidth. The other one is talking about, see here they have put straight away 1000. But in some documents, if you see, they will put twice. Twice is because first number is talking about the maximum bandwidth, second number per flow. Instead of showing here, I'll go show in the command line itself. You see interface G 3/0 IPRSVP bandwidth. You see, first is you're going to say how much bandwidth I should give, the reserved bandwidth. I'm going to say now, see, it took 750, no? I'm going to say, no, you can take only 75 meg. And what is per flow? This is per flow. In one flow, what should be the meaning for one traffic, for one flow? What should be the bandwidth? I'm going to say one flow cannot exceed more than 5 meg, something like that. I don't say 5 meg. Okay, yeah, 5 meg you can say. Now, if you go and verify, you see the maximum is 75, per flow is 5. So how many flows I can have now? 15, right? 15 flows. 15/5 is 75. So I can have 15 flows of traffic. And the traffic flow should be within 5. Oh, it's KB. Sorry, no, I don't know. I don't want in KB. I want in MB. I made a mistake. I didn't see carefully when I put question mark. It was in kilobits. Yeah, 750 meg and 50 meg. Now we will see what I was talking. Again, I think I need to put one more 0. Yeah, this is meg. No, I think another 0 will come. Yeah, another 0 will come. 1000 meg, 1000 KB is 1 kilobits, 1 megabits. 1000 kilobits. So 1000 multiplied by 75. 1000 multiplied by 5. Now you will see what we want. Look at this. So in gig Ethernet, it was taking 750 meg earlier because 75% it will take by default. I said, no. You should only take 75 meg out of 1000 for RSVP. All the rest will be for other traffics other than RSVP. And then I said a flow cannot be more than 5 meg. The reason is I want to have many flows in this tunnel. So I can now have up to 15 flows. through the tunnel. 15 flow of traffic can use this RSVP. Okay, so this is clean, looking great. Now what I have to do is I need to go and start configuring tunnel on R1 and R5. See, the path is ready to support the tunnel. Now we are bringing the tunnel itself. Interface tunnel 0, tunnel mode, MPLS traffic engineering. Very important command. Tunnel IP unnumbered, no, simply IP unnumbered loopback 0. Tunnel destination is final 5. All right, and then tunnel destination.
Jay?
Yes.
This command IP unnumbered loopback 0, can we configure it in GRE tunnels?
Why not? Why
Oh,
not? You can.
okay.
So I have given tunnel destination and I have given tunnel mode. Next is the other parameters, like how much of bandwidth this tunnel needs. Tunnel. Okay, source also can be done optionally, loopback 0. Next is tunnel.
So basically IP unnumbered loopback 0 will take
It is going to
loopback.
give the IP address to the interface. It's going to give the IP address to the interface. Okay.
No, it takes the loopback 0 IP address.
Yeah,
Correct?
for the tunnel interface.
Okay.
It is going to take the IP address of the loopback as the tunnel interface. Okay. You see, IP unnumbered. Source is not necessary. It will automatically take, but I have also given source. It is okay. Destination. This is done. Now, for MPLS traffic engineering, how much bandwidth you are expecting? That I need to say. The command is tunnel MPLS. Traffic engineering bandwidth. And now this is also in kilobits. For testing, I want to keep as low as possible. So I want only 1 meg, which is 1000 kilobits. Traffic engineering tunnel needs 1 meg on the path. 1 meg reservation. So 1 meg should be available. Available bandwidth in the path should be 1 meg. Next is the path option. Sorry, the priority. The priority, even if you don't give, it's going to be 7-7. 7-7. See, traffic engineering, MPLS, traffic engineering priority. Set up priority 0 to 7. If you don't set it, is going to be 7. Let's say setup priority is 1. Hold priority is also 1.
What does this command do?
Comparatively, it will decide. See, if there is another tunnel with setup priority 1 and hold priority 2, that won't be preferred. This will be preferred. See, to have more granular in setup priority, you can have multiple hold priorities from 0 to 7 again. So there will be different weightage for this. You see, I'll use a paint.
But is this command relevant when we have only one tunnel?
Not necessary at all. When you have many tunnels, I'm saying very important, very important, very important, very important. This is tunnel 0, tunnel 1, tunnel 2, tunnel 3. If all are very important, then which one should I prefer? That's why I give the holder 1, 4, 3, 2, like this. So now for which one more priority is given? For this one. And next priority is given to this one. Smaller is better, okay? And then this one, and then this one. So in one itself, you have 4 flavors. Sorry. Now anyway, I'm not going to give this. It's going to be 775. Next. Tunnel MPLS traffic engineering path option dynamic. Path option 1 is dynamic. Use the dynamic path. Yeah, done. At last, you need to go to routing protocol OSPF and say, hey, you need to support MPLS traffic engineering. So for that,
Did we give this command, Jay, last time?
here we give router OSPF 1 MPLS traffic engineering. MPLS traffic
No,
engineering.
actually, we also did this lab, but remember that day the tunnel was not coming up.
Yeah, again we tried when you are not there.
Ah, okay.
Okay, MPLS traffic engineering router ID use the same loopback 0 interface. MPLS traffic engineering area that you should use is 0. And we are going to put this on router 5. So we have exposed traffic engineering to OSPF, and now on R5 also I have to configure tunnel interface, so I'll copy that from loopback into the router 1, show run interface tunnel 0. And you see I did not give priority, it is taken automatically. I'm going to copy this to notepad. Select all, copy. This goes on router 5. Okay. So we are expecting the tunnel to come up, but it says line protocol down. Tunnel change state to down. Change state to down. Let me go to all the routers in the path and inform OSPF to support traffic engineering. Show IP interface brief. I see the tunnel is down. Show run section router OSPF. I will put these 3 lines on all the routers using notepad. Wow. The tunnel has come up now. Now let's see, show MPLS traffic engineering tunnels. You see, what we are asking is, we are asking, give me a path which has got 1000 meg to reach this destination. And it says I found a path and it is up. And the path option is 1, dynamic. We've only said dynamic. All right. And signaling is fine. Now, if you ask what is the path, it will show you the path here. It says it goes to router 2. And from router 2, it goes to router 4. So it's not going via router 3. It is going from router 2. This is all router 2's address. Do you agree? The last number is 2. And then it goes to router 4. See, the last numbers are 4. And then it goes to router 5. All right, so this much of bandwidth is reserved for the packet to go. All right, RSVP is good. We got the tunnel up. Tunnel is ready. By configuring RSVP tunnel and tunnel is up. On both sides, I need to check. I have checked on one side. Definitely on this side also you will see. Show MPLS tunnels. Even here it says the tunnel is up. Path is valid. We have not said any explicit path. We asked the protocol itself to decide, and it has decided to go straight from R5 to R4 and R4 to R2 and to R1. R4 to R2 and 1. And now if I shut down this port, see what happens. The path will change. Interface G3/0 shut down. I shut down the thing, the neighbor has gone down, the interface has gone down. Now OSPF would have told RSVP about this. Now if you see, show MPLS traffic engineering tunnels, tunnels. Now if you see, it goes via router 3. You see the number of hops have increased. Even now it is same dynamic, path 1 active, but from 4 it goes to 3. See the topology. From 4 it goes to 3. And 3 it goes to 2, and 2 it goes to 1. So it can dynamically switch to the path. Yeah. So the tunnel is ready. The other exceptional things and optional things we'll do in our next class. Try doing this once in your home.